In this video, we discuss an other case to detect multicollinearity among regression model. The name of this method is high pairwise correlations among regressor. As we know, if we have two regressor and the relationship between them is very high, means greater than 0.80, the range of correlation coefficient is between -1 to +1. So if correlation is greater than 0.8, then this is the sign of the presence of multicollinearity. But if we have more than two variables, two regressors are two independent variables, like discuss this case y is the dependent variable, beta 1 is the intercept term, and three predictors x1, x2, x3 and x4. So in such case, this condition that among two regressors, if the relationship is very high, is not in each case is not very high. So we discuss here the specific example, means high zero order correlation are sufficient, but it is not a necessary condition for the existence of multicollinearity, because it can exist if your zero order or simple correlation is very low. If you have more than two variables and the correlation coefficient, in case of very low correlation coefficient, there is the chances to exist multicollinearity. So we understand this with the help of example. Suppose we have four variables like yi, beta 1, beta 2, x2i, beta 3, x3i, beta 4, x4i, and u is the disturbance term. Sorry, there is four variables, mean one is dependent variable and three is independent variable. So we have three independent variables. In such case, suppose x4 is equal to lambda 2 x2i plus lambda 3 x3i. Lambda 2 and lambda 3 are constant but not 0. So these are constant but not equal to 0, and x4, independent variable x4, have the relationship with x3 and x2. So this relationship is exact, and r square 4.23 means when we regress x4 with x2 and x3, it is equal to 1. R show the coefficient of determination, and in regression we regress x4 on x2 and x3, it is equal to 1. 1 means perfect multicollinearity. So here is the formula of r 4.23 square, r23 square plus r43 square minus 2 r42 r43 r23 over 1 minus r23 whole square. In this specific example, we know that r square is equal to 1, 4.23 when we regress our x4, this independent variable x4 with x2 and x3, it is equal to 1. Its coefficient of determination is 1. And these are the given correlations. If we compute Pearson correlation coefficient R, which is simple correlation between R4 and R2, R4 and R2, when we calculate correlation with a simple correlation x4 with x2, it is equal to 0.5. Similarly, R4 x4 with x3, it is also 0.5. Its correlation coefficient, simple Pearson correlation coefficient, which is equal to R. R is equal to 0.5. x4 with this x2, its correlation is also 0.5, and correlation among x2 and x3, which is equal to minus 0.5, Pearson correlation coefficient minus 0.5. So putting these values in this relationship, 0.5 whole square plus 0.5 whole square, 2 into 0.5, 0.5 minus 0.5 or 1 minus 0.5 whole square. So this is equal to 0.25, 0.25 minus minus plus, it is also equal to 0.25, 0.75 over 1 minus 0.25, 0.75, it is equal to 1. It means there is perfect collinearity among this model. But as you know, their correlation coefficient is very low. So in case of more than two independent variables, Pearson correlation coefficient, the check of Pearson correlation coefficient is not sufficient. It may mislead because multicollinearity exists in case of low, as we discuss in this example. So how we conclude? These are the conclusions in this example. Conclusion: model involving more than two predictors. Predictors means independent variable, regressor, predictors, these are also the name of same thing. In case of two predictors, the simple or zero order correlation. Simple or zero order correlation, zero order correlation is also called simple correlation, because when you calculate zero order correlation, we can to check the effect of two variables by controlling the influence of third variable. As we discuss in this example, we calculate zero order correlation means when we calculate correlation between 2 and 3, we affect the influence of x4 0. So it is called zero order correlation and also the name of simple correlation. So zero and simple correlation will not provide accurate check to the presence of multicollinearity when you have more predictors in your model. So if there are only two explanatory variables, zero order correlation is sufficient. In case of two order means your model is like that: y is equal to beta naught plus, suppose beta naught is intercept beta 1 x1 plus beta 2 x2 plus error term. So in this model, when you have two variable, then zero order correlation or simple correlation is sufficient to check the multicollinearity. If its value is greater than 0.80 means there is the presence of multicollinearity. But when you have more than two variables in your regression model, then you cannot check correlation with respect to simple or zero order correlation, because multicollinearity also exists when your correlation coefficient have very low values. Thanks for watching. If you like video, then click on like button and subscribe my channel Statisticians Club. You can find complete videos on the topic of multicollinearity on my channel. I also made a playlist by the name of multicollinearity. You can view the complete playlist. Thanks for watching.